Welcome back. In the last video, we covered the basic building blocks of data representation in deep learning, which is the tensor, or in PyTorch, specifically torch.tensor. But within that, we had a look at what a scalar is, we had a look at what a vector is, we had a look at a matrix, we had a look at what a tensor is. And I issued you the challenge to get as creative as you like with creating your own tensor. So I hope you gave that a shot, because as you'll see throughout the course and your deep learning journey, a tensor can represent or can be of almost any shape and size and have almost any combination of numbers within it. And so this is very important to be able to interact with different tensors, to be able to understand what the different names of things are. So when you hear matrix, you go, oh, maybe that's a two-dimensional tensor. When you hear a vector, maybe that's a one-dimensional tensor. When you hear a tensor, that could be any amount of dimensions. And just for reference for that, if we come back to the course reference, we've got a scalar. What is it? A single number, number of dimensions, 0. We've got a vector, a number with direction, number of dimensions, 1. A matrix, a tensor. And now here's another little tidbit of the nomenclature of things, or the naming of things. Typically, you'll see a variable name for a scalar or a vector as a lowercase. So a vector, you might have a lowercase y storing that data. But for a matrix or a tensor, you'll often see an uppercase letter or variable in Python in our case, because we're writing code. And so I'm not exactly sure why this is, but this is just what you're going to see in machine learning and deep learning code and research papers across the board. This is a typical nomenclature. Scalars and vectors, lowercase, matrix and tensors, uppercase. That's where that naming comes from. And that's why I've given the tensor uppercase here. Now, with that being said, let's jump in to another very important concept with tensors, and that is random tensors. Why random tensors? I'm just writing this in a code cell now. I could go here. This is a comment in Python. Random tensors. But we'll get rid of that. We could just start another text cell here, and then 3 hashes is going to give us a heading. Random tensors there. Or I could turn this again into a markdown cell with command MM when I'm using Google Colab. So random tensors. Let's write down here. Why random tensors? So we've done the tedious thing of creating our own tensors with some numbers that we've defined, whatever these are. Again, you could define these as almost anything. But random tensors is a big part in PyTorch, because let's write this down. Random tensors are important because the way many neural networks learn is that they start with tensors full of random numbers and then adjust those random numbers to better represent the data. So seriously, this is one of the big concepts of neural networks. I'm going to write in code here, which is this is what the tick is for. Start with random numbers, look at data, update random numbers, look at data, update random numbers. That is the crux of neural networks. So let's create a random tensor with PyTorch. Remember how I said that PyTorch is going to create tensors for you behind the scenes? Well, this is one of the ways that it does so. So we create a random tensor, and we'll give it a size of, random tensor of size or shape. PyTorch use these independently. So size, shape, they mean they're different versions of the same thing. So random tensor equals torch.rand, and we're going to type in here 3, 4. And the beautiful thing about Google Colab as well is that if we wait long enough, it's going to pop up with the doc string of what's going on. I personally find this a little hard to read in Google Colab, because you see you can keep going down there. You might be able to read that. But what can we do? Well, we can go to torch.rand. Then we go to the documentation. Beautiful. Now there's a whole bunch of stuff here that you're more than welcome to read. We're not going to go through all that. We're just going to see what happens hands-on. So you can copy that in here and write this in notes. Torch random tensors. Done. just going to make some code cells down here so I've got some space. I can get this a bit up here. Let's see what our random tensor looks like. There we go, beautiful, of size 3, 4. So we've got 3 or 4 elements here, and then we've got 3 deep here. So again, there's the 2 pairs. So what do you think the number of dimensions will be for random tensor? NDim. 2. Beautiful. And so we have some random numbers here. Now, the beautiful thing about PyTorch, again, is that it's going to do a lot of this behind the scenes. So if we wanted to create a size of 10, 10, in some cases we won't want 1 dimension here, and then it's going to go 10, 10. And then if we check the number of dimensions, how many do you think it will be now? 3. Why is that? Because we've got 1, 10, 10. And then if we wanted to create 10, 10, 10, what's the number of dimensions going to be? It's not going to change. Why is that? We haven't run that cell yet, but we've got a lot of numbers here. We can find out what 10 times 10 times 10 is, and I know we can do that in our heads, but the beauty of Colab is we've got a calculator right here. 10 times 10 times 10, we've got 1,000 elements in there. But sometimes tensors can be hundreds of thousands of elements, or millions of elements. But PyTorch is going to take care of a lot of this behind the scenes. So let's clean up a bit of space here. This is a random tensor. Random numbers, beautiful, now it's got 2 dimensions because we've got 3 by 4, and if we put another 1 in the front there, we're going to have how many dimensions? 3 dimensions there. But again, this number of dimensions could be any number, and what's inside here could be any number. Let's get rid of that, and let's get a bit specific, because right now this is just a random tensor of whatever dimension. How about we create a random tensor with similar shape to an image tensor. So a lot of the time when we turn images, image size tensor, when we turn images into tensors, they're going to have, let me just write it in code for you first, size equals a height, a width, and a number of color channels. And so in this case, it's going to be height, width, color channels, and the color channels are red, green, blue. And so let's create a random image tensor. Let's view the size of it, or the shape, and then random image size tensor. We'll view the NDim. Beautiful. Okay, so we've got torch size, the same size, 224, 224, 3, height, width, color channels, and we've got 3 dimensions, 1, 4, height, width, color channels. Now let's go and see an example of this. This is the PyTorch Fundamentals notebook. If we go up to here, so say we wanted to encode this image of my dad eating pizza with thumbs up of a square image of 224 by 224. This is an input, and if we wanted to encode this into tensor format, well, one of the ways of representing an image tensor, very common ways, is to split it into color channels, because with red, green, and blue, you can create almost any color you want. And then we have a tensor representation. So sometimes you're going to see color channels come first. We can switch this around in our code quite easily by going color channels here. But you'll also see color channels come at the end. I know I'm saying a lot that we kind of haven't covered yet. The main takeaway from here is that almost any data can be represented as a tensor, and one of the common ways to represent images is in the format color channels, height, width, and how these values are will depend on what's in the image, but we've done this in a random way. So the takeaway from this video is that PyTorch enables you to create tensors quite easily with the random method. However, it is going to do a lot of this creating tensors for you behind the scenes. And why are random tensors so valuable? Because neural networks start with random numbers, look at data such as image tensors, and then adjust those random numbers to better represent that data, and they repeat those steps onwards and onwards and onwards. Let's finish this video here. My challenge for you is to create your own random tensor of whatever size and shape you want. So you could have 5, 10, 10 here, and see what that looks like, and then we'll keep coding in the next video.